Temperatures here hit 130 degrees Fahrenheit, hot enough to warp solid steel. And yet somewhere beneath that shimmering heat there's a railway, tracks stretching across 1,000 miles of nothing. No rivers, no shade, no mercy. You're looking at one of the most hostile building sites on planet Earth. Sand that swallows machines whole, winds that erase roads overnight, ground so hot it can melt the soles of a worker's boots in under an hour. So how do you lay steel rails across a desert that actively tries to destroy everything humans bring into it? How do you stop a railway from disappearing under the sand the moment you finish building it? The answer involves a level of engineering most people have never even heard of. And it starts with a question nobody wanted to ask. What happens when nature itself becomes the enemy? The Sahara isn't just a desert, it's a continent-sized obstacle. At 3.6 million square miles, it's larger than the entire United States. You could fit the whole of Europe inside it and still have room left over. For centuries, this vast ocean of sand cut Africa in half. Trade routes that should have taken days took months. Resources buried beneath the dunes, iron ore, phosphate, oil, sat untouched because nothing could move them out. For thousands of years, camels were the only answer. Caravans crossing the Sahara could take 90 days. 90 days to move goods that a modern train could carry in under 24 hours. That gap between what was possible and what was needed became the seed of one of the boldest engineering visions in African history. The idea of a Trans-Saharan Railway isn't new. French colonial engineers first sketched plans in the late 1800s, dreaming of a line connecting Algeria to the riches of West Africa. They failed. The desert won. Heat cracked their surveying equipment. Sandstorms buried their supply lines. Entire expeditions vanished without explanation. But the dream never died. Decades later, modern nations, Algeria, Nigeria, Chad, revived it. This time with tools the early pioneers couldn't have imagined. Satellite mapping, heat-resistant alloys, machines built specifically to survive conditions that would destroy ordinary equipment in days. The stakes were enormous. A working railway through the Sahara could transform trade across an entire continent. Minerals that took weeks to transport by truck could move in hours. Landlocked nations, cut off from ports for generations, could finally connect to the global economy. This wasn't just a railway. It was a lifeline being threaded through the most unforgiving landscape on Earth. But threading that lifeline meant confronting problems no engineer had ever fully solved. How do you build something permanent in a place where the ground itself refuses to stay still? How do you keep a steel structure intact when the temperature swings nearly 80 degrees between noon and midnight? These weren't hypothetical questions. They were the daily reality facing every engineer who set foot on this project. And the solutions they found would push the boundaries of what railway engineering thought was even possible. Here's the first problem: sand doesn't just sit still, it moves. A single sandstorm can shift enough material to bury a finished railway line overnight. Imagine spending months laying track, only to watch the desert erase it in a single afternoon. This happened more than once during early surveys. Entire sections vanished beneath fresh dunes before crews could even celebrate finishing them. So engineers had to think differently. Instead of fighting the sand, they learned to read it. Using satellite imagery and decades of wind pattern data, teams mapped exactly where dunes were likely to migrate. Then they routed the railway around the most volatile zones entirely, like a sailor charting a course around a storm rather than through it. But avoidance only solves part of the problem. In areas where the track had no choice but to cross active sand zones, engineers built something surprising: barriers that look almost like fences, made from compacted vegetation and angled windbreaks. These structures don't stop the wind. They redirect it, forcing sand to drop before it ever reaches the rails. Here's fact one most people don't know. These wind deflection systems were inspired by methods used to protect highways in China's Taklamakan Desert. Engineers borrowed a 21st century Asian solution and adapted it for African geography. The second major challenge is heat, and this one attacks the railway itself, not just the ground beneath it. Standard steel rail expands in extreme heat. In temperatures that regularly exceed 120 degrees, ordinary track would buckle, twist, and warp within a single season. So engineers used specially treated steel alloys, designed to expand and contract without losing structural integrity. They also left calculated microgaps between rail segments, nearly invisible to the eye, but essential to prevent the entire line from bending under thermal stress. Surprising fact number 2. In some sections, ground temperatures get so extreme that workers can only operate machinery during specific 4-hour windows at dawn and dusk. Midday work isn't just uncomfortable. It's physically dangerous, both for human bodies and mechanical equipment. Then there's the foundation problem, perhaps the most counterintuitive of all. You'd think you need a perfectly flat, hard surface to lay railway track. In the Sahara, hard ground is rare. Sand layers shift beneath the surface in ways invisible from above. Engineers solve this using a technique borrowed from offshore oil platforms: deep pile foundations. Concrete pillars driven dozens of feet into the substrate, anchoring the track to stable rock layers far beneath the shifting sand. It's essentially building a railway on stilts, buried underground. Surprising fact number 3. Some foundation pillars had to be driven over 60 feet deep, deeper than a 6-story building is tall, just to find ground stable enough to trust. Every solution engineers found here wasn't borrowed from typical railway construction. It came from oil rigs, highway projects, and desert ecology research. But knowing the theory is one thing. Surviving the execution is another story entirely. Construction crews working in the deep Sahara face conditions most humans never experience. Water trucks had to travel hundreds of miles just to keep workers hydrated. A single mechanical breakdown could leave a team stranded for days, far from the nearest town, with temperatures that turn dehydration into a life-threatening emergency within hours. In 2019, during preliminary surveying for one proposed Trans-Saharan corridor, a logistics convoy lost contact with base camp for nearly 36 hours after a sandstorm disabled their communication equipment. Search teams eventually located them using emergency satellite beacons, stranded but alive. This is the reality engineers had to plan around constantly. Every supply chain, every worker rotation schedule, every piece of machinery had built-in redundancy, because failure in the Sahara doesn't mean inconvenience. It means danger. Sandstorms themselves deserve special attention because most people underestimate them entirely. These aren't gentle gusts. Saharan sandstorms can reduce visibility to less than 3 feet, can last for days, and can strip paint off metal equipment through sheer abrasive force. Engineers nicknamed one particularly brutal storm system the grinder, because of how it sanded down protective coatings on machinery in a matter of hours. To survive these storms, construction teams developed an early warning network using weather satellites combined with ground sensors spaced every few miles along the build corridor. When storm patterns were detected, crews had as little as 45 minutes to secure equipment and retreat to shelter. 45 minutes to protect millions of dollars in machinery from a force of nature that doesn't negotiate. Here's something most documentaries never mention: the human cost of isolation. Workers on Trans-Saharan rail projects often spend 6 to 8 weeks at remote desert camps before rotating out. No cities nearby, no quick trips home, just endless horizon and the hum of machinery. Psychologists who studied similar remote engineering projects, including Arctic pipeline construction, found that prolonged isolation in extreme environments creates measurable psychological strain, leading many modern desert projects to mandate strict rotation schedules and on-site mental health support. Then there's the wildlife factor, something engineers genuinely didn't expect. The Sahara isn't empty. Scorpions, venomous snakes, and even desert foxes regularly wander into construction zones, drawn by shade from equipment or stored water supplies. Crews had to be trained not just in engineering protocols, but in basic desert survival and animal encounter response. One case that became legendary among construction teams: workers at a remote outpost discovered an entire colony of desert ants had built nests inside stored construction materials, requiring a full supply chain decontamination before equipment could be used safely. Nature, it turns out, finds a way into everything, even steel. Perhaps the most underappreciated challenge is logistics itself. In normal railway construction, supply depots sit nearby. In the Sahara, the nearest major supply hub can be over 500 miles away. Every bolt, every steel beam, every liter of fuel has to be planned weeks in advance, because there's no running to the store when something's missing. This is why some experts argue Trans-Saharan rail projects are less about railway engineering and more about logistics engineering. The actual track laying is almost the easy part. Getting materials, water, and people safely to the build site, and keeping them alive while they work. Let's talk about the facts that most people never hear. First, the scale of sand movement here is almost incomprehensible. Some Saharan dunes shift as much as 100 feet per year. That means engineers aren't just building a railway. They're building a railway that has to survive a desert that's literally rearranging itself in real time, year after year. Second, temperature swings here are more extreme than almost anywhere else on Earth. Daytime highs can hit 122 degrees Fahrenheit, while nighttime temperatures can plunge to near freezing. That's a daily swing of nearly 80 degrees. Imagine your house heating to a sauna by noon, then dropping to refrigerator temperatures by midnight, every single day, forever. Third, and this one genuinely surprises people, parts of the Sahara actually flood. Flash floods. In a desert, rare desert rainstorms can dump months' worth of water in a single afternoon, and because the sand can't absorb it fast enough, the water rushes across the surface in destructive walls. Engineers had to design drainage systems for a desert railway, accounting for floods most people assume could never happen here. Fourth, for scale, consider this. The total length of proposed Trans-Saharan rail corridors stretches over 25 miles. That's roughly the distance from New York City to Los Angeles. Now imagine building that entire distance through a landscape, actively trying to bury, melt, or blow away everything you create. Fifth, here's the controversial part. Not everyone agrees this railway should exist at all. Critics argue the environmental cost of cutting infrastructure through one of Earth's last truly untouched landscapes could disrupt fragile desert ecosystems that took thousands of years to stabilize. Saharan oases, underground water reserves, and migratory wildlife corridors could all be affected by large-scale construction. Supporters counter that economic transformation for landlocked African nations is worth the trade-off, that connecting resource-rich but isolated regions to global trade could lift millions out of poverty. Both sides have genuinely compelling arguments, and even among engineers working on these projects, opinions remain divided. There's also debate around cost. Estimates for full Trans-Saharan rail completion range into the tens of billions of dollars, with some economists questioning whether air and improved road infrastructure might deliver similar benefits at a fraction of the price and environmental risk. What nobody disputes, though, is the sheer audacity of the attempt. Whether you think this railway should exist or not, the engineering required to even consider it pushes against the absolute limits of what humans have figured out how to build. This isn't just a transportation project. It's a real-time experiment in whether human ingenuity can outlast one of the most hostile environments our planet has ever produced. So let's bring this back to where we started. A railway across the Sahara isn't just steel and concrete. It's a battle between human ambition and a landscape that has spent millions of years perfecting the art of destruction. Every mile of track represents wind redirected, heat outsmarted, and foundations anchored far deeper than anyone thought necessary. Engineers didn't just build a railway. They built an entirely new set of solutions, borrowed from oil rigs, highways, and decades of desert science nobody had ever combined quite this way before. And the story isn't finished. Sections of this railway are still being planned, debated, and built right now, even as you watch this. The desert hasn't given up. Dunes are still shifting. Storms are still coming. And engineers are still adapting, mile by mile, to a landscape that refuses to make this easy. Here's the question worth sitting with. If humans can engineer their way across the harshest desert on the planet, what does that tell us about the limits we assume exist everywhere else? Maybe the real story here isn't about sand, or steel, or heat-resistant alloys. Maybe it's about what happens when people simply refuse to accept that something is impossible. If this changed how you see the world, hit subscribe. We uncover the truth behind things you thought you already knew. Because somewhere out there, right now, in 120-degree heat, a crew is laying down another section of track, pushing a railway 1 mile further into a desert that never asked to be crossed. And whether you ever set foot in the Sahara or not, you'll know the truth behind those rails the next time someone calls a desert empty. It never was.